So this lesson is on finding x and y intercepts. The x-intercept is going to be where it crosses the x-axis. So right here, this is your x-intercept. The y-intercept is where it crosses the y-axis. So this is going to be your y-intercept. The way you write intercepts, your x-intercept is always going to be a number and then a 0. So like this x-intercept is 2, 0 because it's over at 2. The y-intercept is opposite. It's always going to be 0 and then a number. So this y-intercept is at 0, -6. Okay. So let's do some examples. The x-intercept is on my x. This is my x-axis. So my x-intercept is right here. So I would write that as -2, 0. And you have to write them as ordered pairs, okay? The x-intercept is at -2, 0. The y-intercept is on my y-axis. So here's my y-axis, and it crosses right here. So your y-intercept is at 0, and it's up 1. So that's my y-intercept. So let's try this one. My x-intercept is right here, which is at -2, 0, right? There's -1, that's -2. My y-intercept, remember the first number is always 0, and it's up here at 1, 2, 3. So my y-intercept is 0, 3. Okay, what do you do if it's not graphed? Well, it's pretty easy. To find the x-intercept, you plug in, I'm going to type this because you do need to write this in your notes. So let's type this. To find the x-intercept, plug in 0 for y. To find the y-intercept, plug in 0 for x. Okay, put that in your notes. You're going to need that. And then we'll do number 1. So to find the x-intercept, plug in 0 for y. To find the y-intercept, plug in 0 for x. So I'm going to start by finding the x-intercept. So, whoops. To find the x-intercept, we're going to plug a 0 in for y. So right here, instead of y, I'm going to plug in a 0. Now, wherever you plug in the 0, you can just mark it out because anything times 0 is 0. So my x-intercept is at 12. And remember, write it as an ordered pair, so it would be at 12, 0. The y-intercept, we plug in 0 for x. So here, instead of x, I'm going to plug in a 0. And remember, when you plug in 0, you can just kind of mark it out. It's gone. So I have -2y equals 12. I need to solve this. These are multiplying. The opposite of multiplying is division. So I'm going to divide by -2 on both sides. And 12 divided by -2 is -6. So my y-intercept, remember the 0 comes first, is at -6. Okay, let's do another one. Let's find the x and y intercepts. So I'm going to start with the x-intercept. So to find the x-intercept, we put a 0 in for y. 5 times 0 is nothing, so those cancel. So I have -3x equals 9. To solve this, I want to divide by -3. And 9 divided by -3 is -3. Remember, write it as an ordered pair. So my x-intercept is at -3, 0. Y-intercept, I plug in 0 for x. -3 times 0 is nothing. So I have 5y equals 9. To solve this, I would divide by 5 on both sides. So y equals, you could put 1.8 or leave it as 9/5. I'm going to leave it as 9/5. So my y-intercept is at 0. 9/5. I'm going to let you guys try this one, so if you'll pause it and try this, and then we will go through it. Okay, hopefully you attempted this. Now let's go through it. So your x-intercept, you should have plugged a 0 in for y, which means these cancel. So 2x equals 12, and then divide by 2. And your x-intercept is at 6. Write it as an ordered pair, so it's going to be at 6, 0. Here, plug in 0 for x, so those go away. Now make sure you bring down a negative 4y equals 12. You'll divide by negative 4. And 12 divided by negative 4 is negative 3. So your y-intercept is at 0, negative 3. Special cases. So this one is a special case, y equals 7. There's no x's in here, or to plug anything in. So if it's y equals a number, that means there is no x-intercept. Because this graph is going to go through up at 7. 1, 2, 3, 4, 5, 6, 7. It's going to be a horizontal line going through at 7. So there's no x-intercept. And the y-intercept is going to be at 0, 7. So that's the first special case, when you will have no x-intercept. If it's y equals a number and there's no x, then that means there's no x-intercept. The other special case is if it says x equals a number. So this one has no y-intercept. And the x-intercept is going to be at 2, 0. This graph is going to look like this. It's going to go through 2 at your x-axis, and it's going to be a vertical line. So that's that graph. All right, so of course it's got to get a little bit harder. You will have word problems where you're going to have to explain in words what do the x and y intercepts mean. So let's just go through this example. So Trish is running the 200-meter dash in 25 seconds. The function 200 minus 8x gives the distance remaining to be run after x seconds. Graph the function and find its intercepts. What does each intercept represent? All right, so let's start with, excuse me, is it continuous or discrete? Well, let's first talk about what are we even talking about? We're talking about distance, right? She's running a 200-meter dash. And we're talking about seconds, okay? This one is kind of nice because it tells me that x is seconds, which means seconds is going to go on my x-axis, which means distance is going to go on my y-axis. So if we're talking about distance and running, is that going to be continuous or discrete? Are you going to continually run this distance, or are you going to stop and then magically go to another spot and then magically go to another spot? You are going to continuously run. So this one's going to be continuous. Let's graph it. Our distance that we're running is 200 meters. So I'm going to go up by 20. So I'm going to do 20, 40, 60, 80, 100, 120. You guys should be labeling all of these, but it's hard to write on this, so I'm just not. 120, 140, 160, 180, 200. And time, it's 25 seconds. So I'm going to go by 5. So this is 5, 10, 15, 20, 25. So let's graph this. It's going to start at 200 because that's where she is. And then she's running, and she's going to end the race at 25 seconds. So I'm going to connect these because it's continuous, right? So that means it's going to be a straight line. So there's my graph. So let's look at the x-intercept. What is this x-intercept? It is at 25, 0. What does it mean? Well, let's look at words that I need to use. I know that I'm talking about a race, okay? I know x-intercept is really seconds. So how can I use 25, talking about a race, and seconds to finish, to write this statement? Think about that for a second. Hopefully you can process and say, well, that means she finished the race in 25 seconds. So what does my x-intercept mean? It means Trish finished the race in 25 seconds. That's what it means. Okay, let's do our y-intercept. My y-intercept is right here at 200. So my y-intercept is at 0, 200. What does it mean? Well, again, let's look at words that we have. We're talking about distance. We're talking about a race, and it's 200. And if you're not sure, reread the problem and see if that gives you any hints. So we're looking for 200, something about distance, and she's running a race. So we need to use those words. So think about that. And hopefully, I mean, it doesn't have to be the sentence exactly like mine, but somehow you need to be saying, Trish ran 200 meters. Or you could say, Trish started 200 meters away from the finish line. You could say the race was 200 meters long, anything like that, okay? All right, let's go through domain. Remember, domain is your x values. So let's look. We're talking about time. X is time. Could you have negative time? No, okay? How about 0? Could you have a time of 0? Yes, you could. 0 is when the race is starting, okay? So the race is starting. Remember, with domain and range, you use inequalities. Domain is x. And then how long did the race last? Well, it lasted 25 seconds. So that's your domain. Range, again, is your y. We're talking about distance. Can you have a negative distance? No. Could you have a distance of 0? Yes, right? That's when it's over. You hit the finish line and your distance is 0. Range is y. And how far away how much did she run? She ran 200 meters. All right, let's do another one like this where it asks me tons and tons of stuff. This one, the school sells pens for $2 and notebooks for $3. And the equation is 2x plus 3y equals 60. Describe the number of pens and notebooks you can buy for $60. So this is important. Bam, pens are x and notebooks are y. So let's start graphing. I got pens down here and I got notebooks here. Is it going to be continuous or discrete? Well, let's think. Can you buy 2.2 pens? No, you cannot. Same thing with notebooks. You're not going to buy 3.6 notebooks. So that means it is discrete. You're going to buy whole ones. So we're going to have dots. This is not going to be a continuous graph. We're going to have dots. We're talking about pens. So I'm going to go up by ones. I'm going to do 1, 2, 3, 4, 5, 6. Okay, actually that's not, we're going to run out of room. We need bigger numbers than that. So I guess let's start with figuring out how many numbers we're going to need. My equation, I'm going to start with that. 2x plus 3y equals 60. So this problem before was easier because it told me I'm going to start at 200 and I'm going to end at 25. This one doesn't tell me where I'm going to start and where I'm going to end. So I actually have to do the math to figure out the x-intercept and the y-intercept. But you just learned how to do that. So your x-intercept, we're going to plug a 0 in for y. So 2x plus 3 times 0 equals 60. This we don't worry about. So 2x equals 60. Divide by 2. And your x-intercept is going to be at 30. 60 divided by 2 is 30. So my x-intercept is at 30, 0. Let's find the y-intercept. Y-intercept, you plug a 0 for x. Two times 0 is nothing. So I have 3y equals 60. I'm going to divide by 3. And your y-intercept is 20. So my y-intercept is at 0, 20. So I need to get bigger numbers, okay? So I'm going to go up by, I need to get up to 30 on my x, so I'm going to go by 2s. So I'm going to do 2, 4, 6, 8, 10, 12, 14, 16. I still don't have enough. All right, just kidding. Let's go up by 3s. So let's do 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Nice. Y's, I need to get up to, to 20. So I'm going to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So let's put a a dot here and a dot here because I'm going to end at 30. And then we need to figure out where all the rest of our dots go. So there's a couple ways you can do this. I think the easiest way is to solve it for y and let my calculator do the rest. So to solve for y, this is the very first lesson y'all had. You want to move your 2x. I'm going to minus 2x on both sides. So 3y equals, I'm just going to write 60 minus 2x. You could put negative 2x plus 60. It's not wrong, okay? And then I need to divide by 3, everything by 3. So y equals 60 divided by 3 is 20. 2 divided by 3 is just going to stay 2/3 x. So let's grab our awesome calculator, and I'm going to show you how to generate a table in your calculator. It's pretty awesome, actually. Go to y equals, clear out anything that's there, and we're going to type this in. 20 minus 2/3. To do 2/3, you just do division. 2/3 x. And instead of graph, we're going to hit second graph. Because if you see right here in yellow, it says table. That's what I want to get to. So I'm going to do second graph, and I get this awesome table. And look, it tells me, hey, there's your x-intercept. It's at 0, 20. And we're only going to do whole numbers, right? Because can we have 19.3 notebooks? No, we cannot. So I'm going to put a dot at 318. So at 318, I'm going to have a dot here. Oh, I need to get color. 318, I'm going to have a dot here. I'm going to scroll on down. Right here, I'm going to have a dot at 616. So I'm going to go over 6. I'm going to go up to 16. All right, let's keep going. I'm going to have a dot at 9 and 14. And hopefully you see there's a little pattern happening here, right? Well, if I could plot points the right way. So 6 is here, it should be here. And then 9 is here. So each time, each dot, we're going down 2 and over 2. So I'm just going to fill in the rest. If you weren't sure and you didn't see that pattern, you could just keep going through your list and getting these points and plotting them until we finally end up at 30. Okay, so should I connect those dots? No, you should not, because it is discrete. Okay, so let's talk about what they mean. This is actually easy. So it's a word problem, talking about buying stuff. Let's start with the x-intercept down here at 30. What am I talking about? It's written right here. I'm talking about pens. So how can I use 30 in pens, and we need to use this $60 somehow. So think of a statement. What could we write? Again, it doesn't have to be word for word what I'm about to type, but somewhere along these lines. You can buy 30 pens for $60. That's what the x-intercept means. So now that I did that one, see if you can figure out the y-intercept. Okay, hopefully you put something like, you can buy 20 notebooks for $60. Okay, let's talk domain. Well, it's not continuous, so I'm not going to write it like I wrote my other one. I'm going to write the set of numbers. Could you buy negative notebooks? No, you cannot. Can you buy 0 notebooks? Sure can. According to this problem, I do realize technically you could buy 1 notebook, but well, I wouldn't count it wrong if you put 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 30. I'm just going to put the dots that we graphed. So I graphed at 3, and 6, and 9, and 12, and 15, and 18, and 21, 24, and 27, and 30. That's where I ended. So that's what I would put for domain. Range, same thing. Can you buy negative notebooks? Sure can't. You could buy 0. You could also buy 2 or 4. Again, the ones I graphed. 2, 4, 6, 8, 10, 12, 14, 16, 18, or 20. Again, I'm not going to count it wrong because technically, I mean, you're right. You could buy 1 notebook and 1 pen. But I'm just going by the points that we plotted, okay? I think this, okay, we got 2 more. An amateur filmmaker has $6,000. There's our function. Okay, let's look and see if it tells us our x and y. It does. It tells me x is going to be hours. And does it tell me y? No. Okay, so let's figure out. We're talking about time and money. So I know that that y has to be my money. And my x is going to be my hours. Okay, this is another one. It doesn't, well, it does. I'm going to start at 6,000 because that's how much money I have. So I'm going to go up to 6,000, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. But hours, I don't know. Okay, so what I'm going to do is I'm going to figure it out in my calculator. You could do the whole x-intercept, find the x-intercept, find the y-intercept the way we just did it, or I'm going to do it like this, 75x. I'm going to hit second graph again because I want to go to that table, and I want to find, there's my y-intercept at 0, 6,000. So I'm going to scroll down until I get to 0. Woo! Buckle up. We're going to be scrolling for a little while. Let's see how far down I need to go to get to $0. We're almost there. There. All right. So to get to $0, it's going to take 80 hours. So let's write our intercepts. My x-intercept is at 80, 0. My y-intercept is at 0, 6,000. Whew, that looks rough. That's a 0, and that's 6,000. All right, so hours, I need to get out to 80, so I'm going to go by tens. I'm going to do 10, 20, 30, 40, 50, 60, 70, 80 hours. I'm going to put my dot there. Continuous or discrete? Well, let's see here. Could you work 1.5 hours? You sure could. Could you work 3 hours and 20 minutes? You sure could, which means it's going to be continuous. If you can do halves, it's continuous. So I'm going to connect these dots. So there's my graph. What does it mean? Okay, again, I want to look at the words. So I'm talking about hours. I'm talking about 80. I'm talking about money and buying someone and running this. What am I doing? Hours of production. So what does 80 mean? Again, it doesn't have to be word for word, but something along these lines. You can afford to film 80 hours because you only have $6,000. So if it costs more, if it films more than $80, you can't afford it. And let's talk about the money, the $6,000. It is money. So that says, and it's actually in the first sentence, you have $6,000 to spend. Something along those lines. Domain. Can we have negative hours? No. So it's going to start at 0. Domain is X. And it's going to go up to 80 hours. Now, I don't write it out at each individual number because it's continuous. If it's a continuous graph, we write our domain like this. Same thing with range. I don't have negative money, so I'm going to start at 0 money. Range is Y, and it goes up to $6,000. Okay? All right, one more, guys. Stick with me. Here, we're talking about selling hamburgers and hot dogs. Does it tell me which is which? No. So let's be smart and let's figure out X and Y, which one's hamburgers and which one is hot dogs. So look at this equation. 3x. 3x. Where else in our equation do I see a 3? I see a 3 right here, which means hamburgers are going to be your X. So hamburgers are going to be my X. And just to, verify, it says 2y. Well, where do I see a 2? Right here. Hot dogs are $2. So that means my hot dog is going to go right here. And total I have 30 bucks. So let's figure out continuous or discrete. Well, are you going to buy half of a hot dog? I wouldn't. So that's going to be discrete. This is another one where it doesn't tell us our X and Y axis, so we're going to have to figure it out. So my X-intercept, I plug in 0 for Y. Actually, nope, I'm going to use the calculator. I'm just going to do this once. 3x plus 2y equals 30. Let's solve this for Y. Move your 3x first. 3x's cancel, so 2y equals 30 minus 3x. Divide by 2, divide by 2, divide by 2. So y equals 30 divided by 2 is 15 minus 3 divided by 2. You can put 1.5 or leave it 3 over 2. It doesn't matter. So let's grab our awesome calculator. Go to y equals, clear this out. Let's do 15 minus 1.5x. Let's go to our table and let's go up because we're in negative money right now. And up and up and up. Okay, I'm going to stop right here. This is my x-intercept. It's at 10, 0, so let's go ahead and fill that in. My x-intercept is at 10, 0. And let's go up and find my y-intercept. My y-intercept is at 0, 15. So, here I need to go out to 10, so I'm going to go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here I need to go up to 15. What do I want to go by? Let's go by 3s. So 3, 6, 9, 12, 15. So I'm going to put a dot at 15. I'm going to put a dot at 10. Not going to connect them, so I need to find out what other dots to put. Again, I'm not going to do the decimal ones because you're not going to buy 13.5 hot dogs. I could buy 2 and 12. So 2 and 12 would be right about here. I could do 4 and 9. 4 and 9, that would be here. Oh, I went by ones. Dadgum. I'm losing my mind, y'all. Let's try it again. So 2. 212 is going to be here. 212. 410 is going to be out here. 6 is going to be here, right? 1, 2, 3, 4, 5, 6, yeah. And then I'm going to have one here at 8, here, at 8, 3, and then at 0, 10, or 10, 0. All right, what do they mean? Well, we got to use hamburgers and the number 10, and we got $30. So, should sound something like this. You can buy 10 hamburgers for $30. So now that I've done that one, you guys try your Y. Okay, hopefully you can buy 15 hot dogs for $30. Domain, can you buy negative hamburgers? Nope, we can buy 0. And again, this is like the pencil pen ones. I would not count it wrong if you could buy 1 or 2 or 3 or 4, but I'm just going to put the ones I graphed. So I graphed 2, 4, 6, 8, and 10. Range. Can you buy negative hot dogs? Nope. But 0, 3, 6, 9, 12, and 15. Those are the ones I graphed. So if you will go try the worksheet on finding intercepts and turn it in.